Hello students. So we are now discussing question number 92 of KVPY SX 2021 paper. This is second question of part 2 of physics. So let's see what the question says. It says that a cubical metal blocks of mass 5 kg, edge length zero point 0.1, initial temperature 100 degrees Celsius is placed on a thermally insulated flat surface. So if this is the surface, then there is a cube kept over it. Okay, and it is exposed to air at 0 degrees Celsius. The time in seconds required to cool the block from temperature to a temperature of 37 degrees Celsius is closest to. So we've been given the data. The specific heat of the metal is given, the heat transfer coefficient from the block to air. Now what is this heat transfer coefficient from block to air? So basically, if the block is at a temperature T, the surroundings are at a temperature of 0 degrees Celsius, then some loss of heat will take, and that will be proportional to the temperature difference. So by looking at the unit, we understand that the loss of heat, okay, can be written as 50 times the area. Like this is given 50 watt per unit area per degree Celsius. So we will multiply the area, and the relevant area in this case would be the area from which the loss of heat will take place, and that area will be the area of the 5 sides which are exposed to atmosphere. Mind you that there are 5 sides which are exposed to atmosphere, not 6. So we are going to write 5 into area of one side. Now length of one side was 0.1, so it will be 0.1 into zero point 0.1 square, and then we will multiply it with the temperature difference, which is T minus 0. I'm taking this T in degree Celsius. 0 is also in degree Celsius because the units that are given here are per unit degree Celsius. So now we are having this in appropriate unit. Like this number represents the unit of watt, which should be like that. Now, because of this loss of heat, the temperature of the solid or the temperature of this metal block is going down. So we can replace mod of dq by ms dt by dt with a negative sign, because temperature is decreasing with passage of time. This equals to, this value will become 250. 250 into zero point 0.1 square will become 2.5. So this is 2.5 into T. And now we'll just substitute the value. Mass is given to us as 5 kg. S is given to us as 500 joule per kg per degree Celsius. So 500 per, all the other units are SI units, so we need not take care. Like degree Celsius is there, but that's okay. Because we are dealing with degree Celsius only, so it will become dt by d is equals to 2.5 into dt. So this becomes how much? Like I can cancel this 2.5 with this 5, so it will become minus 1000, and then ln t is equals to t, the limit of temperature and the limit of time. So 0 to t is what we are trying to calculate, and temperature changed from 100 degrees Celsius to 37 degrees Celsius. Okay, so this will become minus 1000 into ln. I'll change the minus to plus, so it will become 100 upon 37 is equals to t. So from here we get the value of 1000 ln 100 by 37. So once you finish this calculation, you are going to get a value which is very close to 1000 seconds. So I did this calculation using a calculator, but once you do it, this is the value that you are going to get. And if we look at the option B looks like we're getting a value which is close to option B, so option B will be the answer. So I hope you understood the solution, guys. Do inquire about Vedanta Economy if you don't know about it already, and do scan this QR code. Thank you, students. Bye bye.